This dipole. So dipole we have two words here. One is di, second is pole. This is di, second is pole. Di means two. These two poles. Poles mean charges, right? So two charges is the meaning of dipole, right? So what is the actual importance of dipole? What is dipole? So everything we will discuss here. So dipole equal to two charges. Okay. So this is the definition of dipole. So two charges of equal magnitude but opposite in sign, right? Plus q and minus q, and separated by distance 2l is known as dipole. So these two charges, distance is 2l, with plus and minus is a dipole. Okay. So why 2l? Because in some textbook they are writing 2d or d or l. All are okay only, right? But this standard 2l. Okay. So the definition of a dipole is two charges are there like this, right? Plus q and this is minus q. Two charges of equal means q values are equal but opposite in sign and separated by distance 2l. This is called dipole. So why dipole? What is the importance of dipole? Now these are the some of the questions we can analyze here by seeing the diagram. Why same charges? Why not same charge? Why same magnitude? Q and Q. Why Q and Q only? Why not the value? Why not the other values? Suppose Q equal 2 coulomb means this one is equal 2 coulomb. Why not 2 and 3? That is first question. Second question is why they should be of opposite in sign. One is plus and minus. Why? That is second question. What is third one is why the distance should be there 2l. Right? So because only which one defining definition is not sufficient here. What is dipole means every one can say two charges of equal magnitude but opposite in sign separated by distance 2l is a dipole. That is the standard definition. Everyone will say. But here we have to analyze here why the charges are equal magnitude. Why of different side? Why distance is there between two charges? Why it is called dipole? So that we have to study here, right? Then only we can understand the importance of dipole here. Now if you see this one, suppose a plus charge here, right? This is a plus charge, this is a minus charge. So already you know an atom having at the center having neutrons and protons, right? And electrons are revolving around the shell. This already you know with this center. If you take another atom with minus, right? Suppose H is H2O, H is plus and O is minus, like that. So this O minus again here, this one also here charges that is neutrons and protons will be there, electrons will revolve like this with the center. So for plus this is the center, for minus this is center, right? Okay. Now when we combine these two, this will be H2O water, right? So if you are combining like this, right? If you are combining like this, right? So what will happen? The covalent bond is formed here, right? What about center? These two centers will be here, right? Centers. One center is here, one center is here. If you are combining, this center will be the center of these two. So here they combining of the which electrons will revolve. That is H2O electrons will revolve with this center. So that we know, because if you take the center of these two, the combination of these two centers will be the middle one, right? So this is happening when the charges of different magnitude means q1 and q2, not q and q, not 2 and 2 coulombs. Suppose if you take q1 equal to 2 coulombs and q2 equal to 3 coulombs, these values are different means this is happening. What is happening? Two charges center, you are getting at center. If the values are different, If the values are same, 2 and 2 or 4 and 4 or 5 and 5, this is not happening. At the center you are not getting. You are getting two centers here, like this. Right? So two centers you are getting here. So when you are combining this plus and minus, so actual center was this, actual second center was this, right? So this center, when you, this is the one more, this minus, two centers you are combining. So when charges are equal, this is 2 coulomb or 2 coulomb, so 2 and 3, this is happening. When 2 and 2 with minus and 1 plus and minus, this is not happening. So you are getting centers like this. Two centers you are not one center. So this is this one. Suppose if you are getting only one center means, you can see here. Suppose one center means these values are not equal, 2 and 3. So 2 minus 3 is minus 1. Minus 1 means suppose this is suppose this is 3 and this is 2. Suppose 3 minus 2 means, suppose if you take example it is 1. So your center will be at this is center, only one center will be there because of different values, and electric field because of 3 and minus 2 plus means your electric field will go, one electric field line will go towards infinity. Suppose this is 5 minus 2 3, so 3 electric field lines will go to infinity. So these electric field lines are escaping whenever the values are not equal, right? So whenever values are equal, what is happening? So when values are equal, what is happening here? Like this. So your values are equal. Values are equal means this is suppose plus 2, this is minus 2, or anything you can take. Plus 12, minus 12, right? So my plus 12 and minus 12 0. 0 means there is no electric field. But here we are getting two centers here like this, not one center. Combination are getting close to this one, because they are close to this one, we are getting two centers, because we are not getting one center here, right? So because of plus and minus, so this plus will moving towards attracting towards minus, and minus to plus, so we are getting two centers here. When values are unequal, plus 3 and which one, minus 4, so here we will get only one center, right? So these two centers, what is happening here? Plus 12, minus 12, zero electric field lines will be there. But here what is happening is, so this electric field lines for plus 12 will move like this. It will radially outward. For this one radially inward, for minus, okay. And plus 2, minus electric field are moving like this, right? Okay. So these are the electric field lines. So a strong electric field is developed when charges of equal magnitude but opposite in sign, it is having two centers here. So that these two centers, this one, this is the center, this is one center, right? Equal mag plus q and minus q, separated by this distance is there, the distance you are taking to L, and you are telling that this is a dipole. So you are getting the distance because of this one. So for a dipole, you are having a strong electric field here, When values are not equal means electric field lines are escaping. So there is no electric, but whenever there are this is strong electric field. This strong electric field is there here, okay. So that is the importance of dipole here. So plus q and minus q separated by distance to L. So that's why this definition is there, okay. So that is the importance of dipole. So whenever charges of equal magnitude but opposite in sign, this one plus q, this minus q, this is 2L, right? This is dipole, because here strong electric field will be there like this, okay. So this is dipole, right? And dipole strength you can find, right? Dipole strength is, you can take this as dipole strength P equal to, means how much strength is there here. So that is P equal to charge, Q is the charge into distance. So this is known as dipole strength, okay. Okay, thank you.